Hi, this is John Adams and thank you for joining me today. This video is one of several in a series on how to speed up your slow PC. In this video, we're going to take a look at the Central Processing Unit, or the CPU. That's the brains of your computer. Every computer has one. Some have more than one. Most desktop and laptop type computers have a single CPU. Now they may have multiple cores inside, and we'll talk about that a little bit later, but generally they just have a single CPU inside of them. These are the three primary brands that modern consumer type computers will have in them as far as the manufacturers. Intel, AMD, and ARM is the third one. Intel and AMD have been around for quite a while, and those are the two most popular. ARM, not so much desktop computers, they're more going into mobile devices, but as the markets start merging and the lines between desktop and mobile start to blur, and it's not going to be long before we probably won't be able to tell the difference between a desktop and a mobile device. But in any case, ARM is coming on very strong because they work in the low power battery operated market segment very well. But these are the three main manufacturers. One of the things I want to talk about is chip design, and I've got three things listed here: single core, dual core, and multi-core. As a user, it's not that critical that you know what that means, except that a couple of things to keep in mind as you go down that list. Obviously, you can see the dollar signs get bigger. That means you're spending more money for more sophisticated chip design. Okay, so without a doubt, that's going to be a priority for you as far as deciding where this technology fits in your budget. The other thing to keep in mind is, generally speaking, as you go down that list, the ability of the CPU to process data is improved, and as a result you'll get a better performance out of your machine. Now there's more to it than just the number of cores, of course, but that's something to keep in mind. And I'll be quite honest with you, single core chips, CPU chips today are pretty much history. If you've still got a computer that has a single core Pentium computer chip, then you probably need to be looking at replacing it fairly soon. Another thing to keep in mind is the clock speed, and as with the number of cores, the faster the clock speed, generally speaking, the more money you're going to spend on that CPU. Now, there's something we'll talk about a little bit later, and it's some computer chips or CPU chips have multiple clock speeds. They do what's called a speed step. They speed up and slow down. So I don't want to confuse that issue with just the core clock speed, which is, you might say, the rated top speed of the chip. And now there's another thing that we can talk about, but only briefly, because generally a typical consumer isn't too concerned about this, and that is overclocking. But what that means is you run the CPU clock at higher than rated speed, but it requires some additional effort on the part of the owner, and in some cases you run the risk of voiding the manufacturer's warranty. So I don't recommend that unless you are an extreme high performance user, in which case you're probably not going to be watching this video anyway. CPU clock speed, number of cores, and then I talked about the speed step. Now what that means, and this is primarily for mobile users. Desktop, you don't see that speed step technology so much. The reason they do this is, in a mobile environment, you're running on battery a lot of the time, and as a result of that, the faster your CPU runs, the more quickly you run down the battery. So let's say that you're downloading web pages, and you're going to sit there a while and read the web page, so you're not a whole lot of activity going on in the background. Why have that CPU running at full speed when you don't need to? So this is what they do when they determine that you're not requiring a high-speed CPU. Then they'll slow it down, and that conserves battery life. And when you start doing something that requires more CPU power, let's say you download a YouTube video and now you need to drive the video on the screen, and you'll need the full CPU high-speed performance in order to drive that video and give you good quality. So it would step up to the higher clock speed. So that's what SpeedStep does, and it's primarily in mobile devices, not in desktop computers. There's something else that I want to point out, and this is important when we think about the whole point of this video series. We're talking about speeding up a slow PC. The CPU clock speed does not slow down with age. So if you buy a computer a year from now, it seems to be running a lot slower. There are other things going on, not that the machine is actually slowing down. This will be discussed in a couple of other videos as well. What's going on most likely is that you have multiple programs running that you may not be aware of, and you're just getting the appearance of a slow PC. Now, the interface that you work with obviously is running slower, and that is correct. It is running slower, but that's only because you've got fewer CPU cycles allocated to the foreground presentation part of the PC operation, and the background, the stuff that you don't see on screen, is consuming a lot of CPU cycles. And then there are other videos where we talk about uninstalling programs, replacing old programs with new programs, things like that. So this video is primarily to discuss the CPU itself, and I want to point out very emphatically, the CPU clock speed does not slow down with age. So when you first bought your PC, if it seemed like it was performing at a satisfactory speed, then most likely you can get back to that level of performance if you follow through all the videos in this series, and we'll take care of business that way. Now, this chart just gives you an idea of what's available out there, and we're looking at a couple of dimensions about CPU performance. One is the design. In the left column you can see single, dual, and multi. Now multi means 3 cores or more. Single core and dual core are older generation designs. Intel and AMD both still make dual core CPUs, but those are on the way out, and it won't be long you won't be able to buy anything but 3 cores or higher. Now again, the mobile market is a little bit different, and I'm talking about tablets primarily. Some laptops are starting to use ARMs. Their architecture is a little different, but when we talk about Intel and AMD CPUs, then the single, dual, and multi-core pretty much all apply. They've been using all of that technology for many years. But as I mentioned, the single core machines are older machines now. This is 2013. I'm not even sure you can buy a single core AMD or Intel chip for a desktop or a laptop computer now. Let's take a look at the chart. The red basically says you might as well get rid of that technology. If you've got a single core computer with a clock speed of less than 1.5 megahertz cycles per second, then you'll never see acceptable performance from that machine. It's a system that you could probably sit in a corner and allow it to run a file server type of application, but you just need to be aware that you're not going to get very good performance out of it. The idea here is if it's just a backup system of some sort and you don't really care about performance, maybe it's ideal for that. But if you're sitting at your desk and you're interacting with it on a daily basis and you're using it for spreadsheets, maybe you're editing video, maybe you're just surfing the internet but you watch movies once in a while or YouTube videos, things like that, you need more performance than what this machine is capable of. In fact, if you go further across the 1.6 to 2.5, 2.6 to 3.0, I've got those as yellow for single core. And the reason, again, is because you're going to get marginal performance out of these machines. They will be acceptable for some things. If you're opening a Word document or an Excel spreadsheet, a small Excel spreadsheet, or if you're downloading email, if you're checking email, then the 1.6, 2.5 on up to 3.0 will give you marginally acceptable performance. And as long as you're doing it because you just want to stay within a budget, and frankly, you can buy these computers now for, in this class, for around $25 to $50 from Craigslist. So there are tons of them out there for sale right now, but you need to be aware that these are very old old machines, and reliability is going to start to become a problem with these machines before too long as well. Then finally, the 3.0 or greater clock speed, those are the high-end versions of the single core machines. And if you're running XP on those machines, you're going to get acceptable performance. The problem, as I mentioned in another video, is that if you're running Windows XP, you're really taking a big risk these days by going online with that machine, because XP has been around so long and the hackers have had plenty of time to figure out the holes in the operating system security, and they're exploiting them even today. And so you're just asking for trouble by going online, because you're at risk of installing viruses. Okay, the next row down is the dual core. I don't even know if they make a dual core with less than 1.0 megahertz clock speed. So the black is there for that reason. And as with the others above, the yellow indicates marginal performance, 1.0 up to 2.5. You can use those, and if everything else is performing satisfactorily, then these machines will work, and they will get the job done. The 1.0 to 1.5 will be slow, there's no question about that, but it won't be painful as long as everything else is working fine. It'll just be on the low end of the performance. In other words, things will download a little bit slower from the internet as you're opening files from your hard drive. As you're starting up programs, they will take a little bit longer. When you're booting up from power off situation to power on and booting up through to Windows, it'll take 10 or 15 seconds longer, possibly 20 seconds longer, to boot up to the Windows desktop. These slower clock speeds will. Now when you get up to 2.6 and higher in a dual core, you should get acceptable performance with no complaints. The last one is the multi-core, 3-core, quad-core. I don't know where we are today in the consumer market. I think they're up to like 8-core and soon to be above that. So they're getting some real powerhouse machines being built. The 1.0 to 1.5, I've never owned one of those, and honestly this is just a subjective assessment. I don't know what kind of performance you'll get in a machine like that, but frankly I don't even know that they make multi-core machines with that clock speed. The 1.6 and up, multi-core, 3-core and up, you're almost guaranteed to get acceptable and better, I think, performance. So if you've got a machine with 3 or more core CPU inside, and you're having performance problems, I can tell you don't have a CPU problem, unless the CPU is failing for some reason. But just slow performance will not be the indication. You'll get other indications. You'll get blue screen crashes. You'll get unexpected. The machine will just halt and the screen will freeze, or it'll shut itself down and reboot and weird stuff like that. If you've got an actual CPU chip problem, more than likely it will not be a slow performance problem that you're suffering from. You've got another kind of problem you'll have to deal with. And we won't be talking about speeding up that machine. We'll be talking about doing some repairs. I do want to show you one more thing. I'm going to get rid of this. In order to determine what you've got in your machine as far as the CPU type and the CPU speed, let's take a look at something. Click on the Windows Start button, and then over here on the right, we've got in the right column, we've got this computer option. So let's right click on that and look at properties. And now what we've got is this screen, and if you look in the center section here, see where it says processor. It tells you the name. This is an AMD processor. It's an Athlon 2 X2 250. Now, this doesn't tell you how many cores, so if you need to know how many cores, then you'll probably need to just go to Google and put that in, and it'll give you can find a website that will give you the specifications. 3.0 gigahertz, you can see that's the clock speed. And if you remember, this is a dual core machine. I'll just tell you that. And if you remember the chart, a dual core that's 3.0 or higher should give acceptable performance, and this machine is quite satisfactory for me. So I can tell you that a dual core at 3.0 is absolutely going to give you good usable performance. So that's how you find out what you've got in your machine, and refer back to the chart. And at this point, like I said, the idea here is to recognize where you are on that chart, on the scale of acceptable performance, and then you need to decide, do I want to continue on testing other things and trying to see if I can resolve my performance problem, or decide, do I have a slower machine that I just can't speed up, and possibly I need to be thinking about replacing it. Thank you so much for joining me today. My name is John Adams, and I hope to see you again soon in a future video.